Today, we'll compare two wall construction methods: aerated concrete blocks, a classic technology, and our Beamex panels. Let's start with aerated concrete. A standard monolithic reinforced concrete frame is constructed, followed by infill walls. In this case, we use two blocks of 100 mm each, resulting in a 300 mm wall. Even with the best masons, it's impossible to achieve perfectly smooth walls due to the inherent inaccuracies in the material, typically around 3 to 5 mm. These are the technological characteristics of aerated concrete. After that, plastering is required by setting up guides and applying plaster along them. Here we face two challenges. First, aerated concrete is a rather dry material, so it needs to be moistened before applying plaster, either by spraying or some other method. However, this is rarely done. The second issue is that the plaster quickly releases moisture into the atmosphere due to Indonesia's consistently hot climate. This causes excessive moisture to be drawn out both towards the concrete and outward. And cement hydration does not fully occur. Hydration is the process where cement gains strength. Due to insufficient moisture, shrinkage causes cracking. Additionally, plaster may start to drum, meaning it detaches from the aerated concrete and sounds hollow when tapped. This issue frequently arises in Indonesia due to the consistently hot climate. What makes these cracks problematic? Firstly, the plaster can simply peel away from the wall in a single layer. If the wall wasn't moistened properly, it may start cracking after a month or two as the plaster hardens, potentially damaging the finish. Performing this work on the exterior is even more challenging due to the sun heating the wall even further. Additionally, these methods involve messy, wet processes that need to be carried out on site. However, there is an alternative: assembling walls from partitions like these. Their sizes are 0.6 meters by 2.4 meters, but it's possible to assemble walls of any height. For example, a 600 millimeter panel can be placed at the bottom and a 2.4 meter panel at the top, creating a 3 meter wall. If a taller wall is needed, they can be installed in a staggered pattern. But that's not the main point. Each panel consists of two layers with high-quality foam concrete at the core, available in densities of D400, D500, or D700, depending on the project requirements. On the exterior are two layers of calcium board. Foam concrete is poured into a specialized formwork between these boards, ensuring the panels come out perfectly smooth. The key feature, however, is the large tongue and groove connection, which makes it impossible to assemble the panels unevenly. As you can see, this wall is built from panels and it's perfectly straight, eliminating the need for plastering with guides. Just apply the putty and the final coating directly, immediately. It significantly saves construction time. You also avoid wet processes like plastering. Unlike aerated concrete, these panels don't face the issue of plaster detachment, since there's no plaster to begin with. Calcium board already serves as a pre-finished surface, eliminating the need for leveling with guides. You can directly apply the final coating or attach any decorative panels. It's not just quality that determines the choice between aerated concrete and panels. Cost also plays a significant role. For instance, if you need to build a wall with aerated concrete, it involves installing the blocks, which is costly, and plastering both sides. You'll also have material waste reinforcement and the challenges of achieving perfectly smooth plastering. On the other hand, with panels, you can simply bring them to the site and install them directly. If you compare two identical walls, one made of aerated concrete and the other from partitions, the partition wall always turns out to be cheaper. As a construction company that purchases both aerated concrete and partitions separately, we know for sure that partitions are consistently more cost-effective. Most importantly, building a wall with partitions is about 7 times faster, since the panels are simply installed and immediately ready for finishing. Another crucial factor is the skill level required for workers building walls from aerated concrete versus partitions. To build a perfect aerated concrete wall, you need skilled masons who can lay the blocks evenly. You also need good plasterers to finish the surface properly. However, to install our panels, you don't need many workers and their high skill levels. This means you can build more walls simultaneously compared to using aerated concrete. Now, let's talk about the convenience of laying communications in walls made from aerated concrete versus panels. How is it done in a typical aerated concrete wall? First, the communications are laid and the sockets are inserted. Then, the wall is plastered. In general, sockets can be inserted later, but this adds extra mess as it requires chiseling. Since we don't know the exact thickness of the plaster, the sockets are installed without precise measurements, and later, it can be difficult to install finishes, such as switches and sockets. But if we consider installing communications in panels, since there won't be a thick layer of finishing, the sockets are installed flush. There will be a thin layer of finishing, for example 2 to 3 millimeters, for plaster and putty, or some decorative panels, and the socket block will be installed. Panels are also very easy to process mechanically. They can be chiseled, communications can be placed inside, and plastered over. If you know, for example, that something large, like an electrical box, will be placed in this panel, we can create an embedment for it during manufacturing. After installation, you simply cut out the calcium board, remove the embedment, and install the electrical box. This leads to even faster construction of your project. Most importantly, it's done without extra mess and guaranteed to be of high quality.